Mechanical Systems and Control. And let me just notify you that we will not be doing assessment as previously scheduled. The assessments were supposed to be this week, but school management changed the assessments to be another time next week. No, let me check. But I will inform you this week. I'll inform you of the exact time frames of the lessons of the just a minute. Okay, so this week we'll be continuing with our lessons. We'll continue revising, and that will give us more time to get ready for our assessments, which have been shifted from this week. Right, and we are revising structure and mechanical systems and control. Right, so we'll be looking at the design process, structures, using pneumatics and hydraulics to obtain a mechanical advantage. Okay. Right. We are going to refresh your memory of the design process. What is included in the design process? So you need to know how to explain the stages of the design process. Now, I'll give you this exercise. I hope some of you did do this exercise before. I thought, because I know it will be in the assessments, let us bring it back today so you remember the answers. Sort out the statements and questions in the correct steps of the design process by arranging them under one of the following headings: investigate, design, make, evaluate, and communicate. So you have to read the statements and arrange them in the order of the design process. Okay, please bear with me. I'm going to take a few minutes. I'm shifting position, okay? I'll just mute myself and shift position. Okay, thank you. Now we are revising the design process. We are going to look at the way we must explain the stages of the design process. So we are going to look at the statements we are given and sort them into investigate, design, make, and evaluate. All right, okay. You just have to say, which stage is this? Okay. You must understand what problem you have to solve or what thing you must design and make. Which stage is that? Let's see. Which stage is that? I'm looking for the answer for this one. Which stage is this? Grade 7, are you with me? Mudiahi, you said it's design. What do others say? You must understand what problem you have to solve. Investigate. Mean? Investigate. Yes, you are correct. I don't know how that answer jumped into that. So you have one answer given to you, bonus. I think the angels brought it. A design brief will state what the product must do and whether it has to be a certain size. What stage is that? Mudiahi, it is investigate, okay? Yeah, where you find out more about the problem. That is investigation, Mudiahi. Then the next one, a design brief will state what the product must do and whether it has to be a certain size. Which stage is that? Grade 7. Are you donating this mark? It is design, correct. Khoyapili. Angelina, correct. It is design. Gather the materials and tools needed. Which stage is that? Where you gather the tools and materials needed. Which stage of the design process is it where you gather the tools and materials needed? Making. It's making. Work safely while you make your product. That's make. What tools do I need? That is still making, right? That's the answer from the angels, right? Does it work? Which stage is that? Evaluate. Mien? Yes, yes, my children, Pele and Lihumo, Angelina Dube, evaluate, where you are testing if it's working. You are testing if it's working in the evaluation stage, but what else is it that you test? You test if it's working. What else? What is, hi Fizana. What is it that you also test during the evaluation stage? What is it that you also test in the evaluation stage? You also test if the product complies with their design criteria, with their specifications. Okay, maybe it does work, but it is not the correct size. Maybe it is not the correct color. So that is where you go back to the specifications of the client, and then you check if the product fits into the specifications in terms of size, in terms of type or color and everything. If it is exactly what the client specified, you do that at the evaluation stage. All right, you go back to the specifications, you check all the specifications if this finished product can fit into all those specifications and it complies. This is what I made that you do in communication. When you present, you say to the client, this is what I made, right? Remember, you can always go back to any other stage if the client is not happy, right? You have a problem, then you are analyzing the problem, you are thinking, what is it that I must be able to do to solve this problem? You are not yet at the how part. You are still trying to find out, what must I be able to do? Okay. How big must it be? Which stage is it? How big must it be? iPhone. Oh, iPhone, what's your name? One of my children is iPhone. iPhone, what's your name? Please tell me your name. How big must it be? That is the design stage. Buhle, thank you, Buhle. Right. So this is a specification. The design stage is where you deal with specifications. What will it look like? What will it look like? Which stage is this? What will it look like? Buhle said investigate. Mian said design. Let's see. Let's design. What will it look like? That is design. Remember, what will it look like? That is a specification. Okay, the specifications come into what it will look like. Okay. Which materials can I use to make it? Where is it that we decide on the materials? Which stage of the design process is it where we decide on the materials? Fizana said design. Let's see. Remember, in the making stage, that is where you compile your cutting list. Your cutting list is your list of tools and materials. You write that list in the making stage, okay? So you have to remember the cutting list, the list of tools and materials goes into the making stage. Okay. Which idea will work best? Which idea will work best? Where we choose, we generate ideas and you choose which idea that you said, Buhle said it's design. Let's see. You're right, Buhle. Fizana, you're right. Fabili, you're right. Angelina, it's design. Okay. I know that at grade 7, these things can confuse us, but this exercise will help us remember name. Right. Think what you will make to solve the problem. Think what you will make to solve a problem. What stage is that? Oh, you said investigate. Let's see. Design. What is it that you will make to solve the problem? Okay, that is the design brief. The design brief goes into the design stage. Okay, the design brief. Think what you will make. Where you say, I will make such and such a product, that is the design brief, and it goes into the design stage. Okay. Draw all your ideas or write comments. Which stage is that? Which stage is that? Draw all your ideas. Where is it that you draw the first idea, second idea, third idea, and then below each and every idea you write comments. Those comments are the advantages and the disadvantages. That is the design. Buhle, you're right. That's the design stage. That is the design stage. So let me quickly discuss with you these descriptions. These descriptions have helped us to remember what this design process entails. Okay, right. In the investigate stage, that is where you deal with the problem. You have your problem statement. You understand the problem. Okay. In the design stage, that is where you have your design brief, where you say, I must design and make such and such a product to solve the problem. Okay? I must design and make such and such a problem to solve. That is the design brief. And then after the design brief, you have your specifications. Your specifications will say what the product or the solution must look like, the size of the solution, the color, what it must be able to do, That is the design, the design criteria. Okay, those are the specifications. Now, in the same stage, you start to draw the solution, the freehand sketches of the solution. Let's say maybe I decide that I must design and make a rocking chair for my grandmother. Okay, then I draw up freehand sketches of different rocking chairs. Okay, maybe another one could be reclining, maybe another one could be made of steel, or another one could be made of wood, you know, and they have different shapes and colors, you know, all that comes into the design. So these three freehand sketches, they are showing different rocking chairs. Then from those, I'm going to look at the first one, then I look at it. I write down the advantages of the first rocking chair design and the disadvantages. I do that for the second and the third ideas. Then in the making stage, that is where I work with the chosen idea. Now, I look at one idea and I choose it. Then the chosen idea, I will then make a working drawing, a two-dimensional drawing of the chosen idea. Now, that is make. It has the working drawing. 2, I will have a plan of how I'm going to, a management plan. I will start by doing this, then do this and do that. Then I also have my cutting list in the making stage. Number 3, I have my cutting list, my list of tools and materials that I'm going to use in making the chair. Number 4, under make, I join the materials. I cut up and join the materials to make the chair. All right. Then that is the making stage, is complete. Then we move to the evaluate stage. In the evaluate stage, I go back to the design stage. I look at the design brief. Have I made a rocking chair for my grandmother? Okay. And I will test it. Does this chair take the weight of a person? You know, those are the specifications. That maybe one of the specifications was saying the chair must be able to carry a load of the load of a person of such a weight, you know. I look at all that. And then I also use a checklist in the evaluate stage. The checklist will have specifications. So I will be ticking yes or no, and I will be commenting in the evaluate stage. And then also, I will be checking with the client to say, my client, is this what you were looking for? Maybe the client will say, yes, your rocking chair is exactly what I was looking for to solve grandmom's problem. Or the client may say, no, this chair is too big. It will not give her support. When she's sleepy, she will be moving around. Maybe the chair must be small enough to, please adjust the chair. So I go back to the making stage, or I can even go back to the design stage and adjust my design and come back to the making stage, to the final drawing, then adjust the sizes there, make some adjustments, and then rework now cut up some materials, maybe to make it smaller or maybe to expand it. Or maybe the client can say, this is a good chair, it can take the weight of grandma, but I want you to change the color, make it lovely. My grandma loves a red color, so you have to adjust. So that's why we say the design process, it's not linear, okay? It's flexible. You can move from one stage to another. But communicate is where you are happy with all the specifications and you can say, yeah, now this is the chair that I'm making. Then you are presenting it. You are showing the client to say, now this is where you adjust the chair. This is how beautiful our Yes, communication. How is everyone doing today? Fizan. Right, so in communication, you are presenting your product. Think if my company is making rocking chairs, then we want to present that to the public to see what kinds of rocking chairs we are making. I think here I can safely say advertisements and form of communication for different companies to say, these are the products that you are making. This is how fantastic our products are. So that is communicate. So the design process is like that. Maybe the company will have to go back to another stage of the design process. If maybe as a community or the consumers, we say, but company X, you're making rocking chairs, but your rocking chairs break easily. I bought mine last year, but it's broken already. So we'll need to go back to the design process to another stage. You can go to the design stage where we generate another idea of better rocking chairs. So that always happens, even with big companies, car manufacturers. You've heard that car manufacturers are recalling a certain model of a car. That's going back in the design process to redesign the car. Maybe when we are busy driving these cars, we have a common complaint to say, this car's brakes, they don't work well and it's not safe. Then report that to the manufacturer of the car. And we hear on TV and our daddies and mummies saying, oh, the company is recalling the car, so we have to take the car back because it has been recalled. It's another stage of the design process where the manufacturer is wanting to improve on their products. So advertisements are communication. Recalling is maybe a step back in the design process to improve on their product. All right. I hope that grade 7 you do understand this process, because throughout your study of technology, even when you do engineering, you will be engaged in the design process all the time. And the design process, it entails keeping records of what you are doing. In the real industrial world, you have what you call your design portfolio. So what you're doing at school is exactly what is being done out there, where you have to investigate and keep a record of that. Design, you keep all these records, and you have to present them, and you have to store them as records of the company, so that if anything happens with the product that you're making, you can go back to the design process as a company. I mean, big companies do that. BMW does that. Sasol does that. All the big companies, coffee making companies do that. Sweet manufacturers. Just imagine if I'm giving my children sweets, they are products of a certain company. If we all complain that our children are developing an allergy to these sweets, that manufacturer has to check into their design portfolio, which contains these stages, to see what has happened, what went into that sweet, which is causing this. So it's an evaluation, then it takes them back to the design process. Okay, right. Now, any questions on the design process? Do you want me to give you a clue of the test? Because I will give you questions on the design process. Now, let's look at structures. Let's chatting. Right. So my children design process. Good. Cool. Structure. Grade 7. You have done structures. How do you describe a structure? How do you define a structure? Yes. I see I have an answer here. What is a structure? For the test, the questions we are having here, they're for the text. How do you define a structure? A structure is an item that has been built to give support, to protect, or to contain. To give support, to protect, or to contain. Okay, you can check your textbook. Different textbooks give different definitions for structures. Okay, but that's the definition. It's one of the definitions I can accept. Let's see. It's something made to start a new design process. A structure unites to support, yes, I would mark that. With stability, yes, I would mark that correct. This one, Khapele and Lihumo, no, 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 right? Structure is an item built to support a load, to span a distance, okay? If you said to support a load, you're correct. To span a distance, you're correct. To contain or protect something. Those are the answers I can correct. Okay. In your own words, describe what you understand by stable. If something is stable, what is it like? If something is stiff, if something is strong. Just jot down your answers or think how you can answer this for 2 marks each. Name 3 principles for keeping a structure stable. And what advantage does the Eiffel Tower have over the Leaning Tower of Pisa? Okay, right. Let us look at your answers. Okay? A structure is something that has been made, natural or man-made, that supports, protects, or contains. Or even if you said that spans a distance, yes. Okay, if something is stiff, if something is stable, it does not fall over. If it's stiff, it does not bend. If it is strong, it does not break. Okay? That's how you describe stable, stiff, and okay. I see. My network was breaking a little. So when we build our frame structures, we want them to be, the question is stable. We want to make them stable. So they should be as low as possible. If something is too high, it can fall over. And for it not to fall over, the center of gravity must be low. So all the heavy materials, we bring them to the bottom, because if they are high, that structure is going to fall. So the center of gravity should be low. What is the center of gravity? All the the heavy members, they should be brought to the closer to the bottom, to the base. The base must be as wide as possible. Think of them electric pylons. The electric pylons, they have a broad base. Have you ever noticed how they look like a dress, right? So the base is broader, right? The base looks almost like a skirt. So that's the shape that makes them to be stable. It gives stability. And the weight at the top should be less than the weight at the bottom. Now that is the center of gravity that I was referring to. Okay, that gives you 6 marks. Now, those are the principles of keeping a structure stable. A broad base, center of gravity, and it should be low as possible. Then, next question, what advantage does the Eiffel Tower have over the Leaning Tower of Pisa? Okay. You can look up those towers. The Eiffel Tower has a broad base, whereas the Leaning Tower of Pisa has a base the same width as the top, thus causing it to tilt. You must look up these structures, see them. One, it looks like this tall building that looks like it's falling over, and tourists, they like taking pictures on it, close to it, because it does look like it's going to fall over. So that shape of the Leaning Tower of Pisa is caused by the fact that the base is not broader than the top. So the Eiffel Tower is actually structurally sound, that in that it has a broad base. The base is broader than the top. Okay. The last question is, why is racing a car stable? Why is a racing car stable, even though it turns corners at high speed? A racing car? Right. The racing car's center of gravity is very low. I want us to talk about that. Why do you say the racing car's center of gravity is low? What features makes the racing car's center of gravity to be low? Think of a racing car. I said when we make the center of gravity to be low in our structures, we take all the heavy and big elements or structural members, we put them near the base or we put them near the bottom. So with regard to a racing car, how can you say the center of gravity is low? What features are we talking about there? Hello? Are you still with me? The center of gravity is low. Think of a racing car. What features is it that makes us think that the center of gravity is low there? It is the big tires, the big wheels of a racing car, right? So those big wheels, they make the center of gravity to be low, 1. 2, racing cars are quite low. That makes them aerodynamic. They cut across the air. So they are designed like that because the air will slow down. The higher the vehicle is, the more interaction it has with air. So to make the racing car aerodynamic, it has to be low. So the center of gravity of racing cars is low because the car is low and the big tires. Okay, you cannot have tires on the top of your car anyway, right? So there's the Eiffel Tower. I got a picture of this. You can go look up the Leaning Tower. All right? Yeah. So that's the Eiffel Tower. Going back to the Eiffel Tower, we said it has an advantage of a broader base. Now, if you can look at this, let's look at the broad base. You see it tapers to the top. It has a tapering shape. And if you can look, there's more material at the bottom than there is on top. So that gives it a good center of gravity. The center of gravity is more to the bottom. So it doesn't look like it's falling. It looks very firm on the ground. And unlike the Leaning Tower, if you can look at the Leaning Tower, it's not tapering. So the base is pretty much the same size of the top. So that is why it has that leaning shape. Right. Now we are going to read this and look at the comparison of traditional structures. You have the domed grass dwelling of the Amangwane clan near Bergville. Right, I'm going to read with you. Expect this in your assessment. You can be given texts from which to read. Okay, I've just been notified. I thought it's an hour. All right. So I will bring this back tomorrow in our lesson tomorrow. I will bring this text and the questions. But do expect your paper to give you some text to read, and then you have to quickly spot what is the technology that you have to identify in the text, all right? And the questions will take you back to the text so that you can engage with it in a technological context. I thought we had 15 minutes left. I will love you and leave you now, grade 7. I hope you benefited from this revision exercise. Please make use of your Sasol Inzalo workbooks and check for the correct answers online if you can. If you can't, if you have some issues that you pick while we are doing that, please share the questions with me in tomorrow's lesson. Okay, bye now. Bye, grade 7.